Welcome to the Power Podcast. I'm Aaron Larson, Executive Editor of Power, and today I'm joined by Reese Mozer. He's the CEO and co-founder of American Robotics. Reese, thanks for joining me. Can you just tell a little bit about your company and what you do?
Sure. Thanks, Aaron. So at American Robotics, we have developed the next generation of drone technology for the commercial sector. And what it is a fully automated drone system that's capable of continuous unattended operation. So once you install this system, autonomous drones work in conjunction with automated base stations to capture and process and analyze and transfer that data remotely to a user. These base stations charge and house the drone to prepare it for each next flight. Once that data is processed and analyzed, it is uploaded, and you can view that through our front end called Scout View, interact with the data and interact with the system. And so, what all this means, this level of automation is key to finally unlocking drones as a viable tool for the energy sector. Before we got started here, you mentioned that we were talking about, or the Power magazine was talking about drones for the past 5+ years. That's pretty common in most commercial industries. Drones have been a topic of discussion for a long time now. But despite all of that hype and discussion, the reality is that until we can remove the human from the loop, drones will not be able to scale to the levels that everybody has imagined. Once we can, it changes the economics of working with the drone. It changes the logistics. Not only does it make it affordable and practical to actually scale, it actually unlocks a whole different type of data collection and thus analysis that we can do on that data, which I'm happy to get into with more detail.
Yeah, it sounds pretty interesting that you're doing this autonomously. First of all, we should talk about what are they being used for specifically? Are they monitoring lines? Are they doing other sorts of activities? Can you explain a little more?
Yeah, so, the use cases for drones in general is quite broad. Our focus in the energy sector are with use cases in oil and gas, in solar, other things like that, and it typically surrounds asset monitoring and collecting data to figure out, has something changed, has something gone wrong, whatever the use case specifically is, it typically falls in the category of anomaly detection. So trying to see, is there a fault on a solar panel? Is there a leak or some corrosion on a pipe? Basically, is anything deviating from what it should be? And, I mentioned the increased ability to do data collection and what that permits in terms of analysis. So to do this type of anomaly detection, which I think we all want to get to, requires a certain type of data. And what that means is you need very high resolutions and you need to collect it very frequently. And so with our system, once it's installed, it will operate multiple times a day, perhaps as many as 20 times a day, every day, indefinitely. You can set it on a schedule and it will just track these assets constantly and determine, has something changed.
The way I understood it, you have little stations where the drone comes back to, it gets recharged, and it goes out again on another mission. So how far are they able to go, and how long can they stay in the air before they have to come back and recharge?
Yeah, so to give you a visual, the base stations, as we call them, are essentially little boxes, hangars for the drone. The base station itself weighs about 600 pounds, and so this is installed in a particular location wherever you want to operate. The area of operation for our drone is typically called a 2-mile radius from where the base station is set up. Part of that has to do with regulatory matters. The drone itself can fly for about 30 minutes. And so it will do its mission, whatever it's attempting to collect data on, collect that data through the flight, come back to the base station, offload that data, charge the drone. While the drone is charging, that data will be processed at the edge within the base station. And once that is finished, that will be uploaded to Scout View.
Okay, and I assume now the Scout View, is that using some sort of artificial intelligence to detect anomalies, or how does that work?
So Scout View is our front-end software. This is an interface platform that you can access from your computer or from your phone. Scout View has a number of functions, one of which is things like scheduling. What asset do you want surveyed at what time? Or controlling Scout to perform a mission on demand. And the other function of it is viewing and interacting with the data that it collects. So within the Scout View program, there are features, things like change detection, anomaly detection, that use some level of AI to do that.
When you go to a power company or an energy company, are you using your drones kind of as a service, or are you selling them to the actual company and setting up a program for them to kind of manage on their own? Or is it both?
Yeah, that's a great question. Yeah, so once you can achieve this level of automation, then we can structure the business model as a service. So we call it robot as a service. You know, this is the final aspect that really puts it all together and makes it practical for companies to really scale and use this technology. So American Robotics handles installation and maintenance and overseeing the operation remotely, and all a customer has to worry about is interacting with the data that it collects.
What we've been talking about since we started the conversation is kind of flying drones. There are also underwater drones. There are land-based drones that drive around. Do you service all types, or are you mainly focused on the flying unmanned vehicles?
Yeah, we're just focused on the aerial aspect. I think there's a lot of opportunity once these technologies really start to permeate through the industry for integration between air and ground and sea vehicles. I think that's all where we're headed. I think, there's a few steps that have to occur before that, but yeah, that's essentially where all this is heading is greater and greater levels of automation as these machines, get better at their jobs and can start to work together.
And I know in the past we have talked about different hurdles with the FAA, and there were some restrictions on how far or beyond line of sight you could go. Has that been basically corrected, or has that problem been overcome? What's the status of that?
Yeah, it has not yet been overcome, and right now that is the primary hurdle stopping this technology from taking off. So right now, American Robotics has developed the technology, the automation, the machine vision, the AI that's required to actually conduct these automated operations reliably in the real world. And the last step for us and for the rest of the industry is to overcome FAA regulations. Beyond line of sight is probably the most key. There's also a list of other ones that would prohibit this kind of automated operation. But, long story short, that hasn't been achieved yet. And that's one of the reasons that we don't see drones flying all over the place right now. Once that's surpassed, you're going to see a pretty dramatic growth in how drones are used in the energy space.
Do you see that coming in the near future, or is there just going to be a lot of things necessary before that occurs?
We expect it in the near future. This topic is something that has been debated over and worked on from both a technology perspective and a policy perspective for really the past decade. And we think that that change is coming quite soon.
I guess the other question I have is about the drones themselves. Are there advancements being made? Are there still opportunities to extend flight times, put in longer life batteries where these things could go more than 2 miles and really, go out for an afternoon, for example?
Yeah, in general, are there continuing advancements today, and will there be more in the future? Absolutely. I think one thing to make clear as we think about the drone industry today is to separate the major divisions of drone markets and the technology that's associated with them. So, one end of the spectrum, you've got consumer drones. These are essentially toys that you manually control, and you can buy in an electronics store. On the other end of the spectrum, you've got very large military drones, and in the middle is commercial drones, and that's what we're talking about today. And so, the level of technology that's required to make commercial drones a reality, particularly when we're talking about automated operation to this level, is quite different than a drone that you would find at Best Buy. For our system, for example, having a drone, fly in a particular pattern and collect images is not that difficult, but everything around that is quite difficult, and what we've been working on for the past several years to make a reality. So that includes things like precision landing, charging, data processing, data transfer, physical storage, the software backend and pipeline to make all of this happen smoothly and reliably, and in a way where it's actually useful, and doing so in a real world scenario where there's wind and different lighting conditions and rain and dust and dirt. So a long list of technical things that have been achieved, and now we're at a point where once this automation is really implemented and the FAA approvals come through, then I think a lot of the focus is going to shift towards general optimization of the drone systems, things like improving endurance time, but also the analytics piece that is enabled by that automation. One more thing I'll note is, with regard to endurance, once you have an automated system that can fly and charge itself automatically 10, 20 times a day, the endurance of the system obviously has less meaning. So that's one of the reasons why automation is required and why it's useful.
All right, it's very interesting, and I think it's definitely something that will be important in the future, and I can just see it being very useful in solar plants to detect, like you said, panels that aren't functioning properly. You can pick them out quickly and easily with the particular camera and infrared and different things like that. So is there anything else that you want to talk about or discuss before we wrap this up?
I would say just in general, kind of repeating some of the earlier discussion about drones, is we've all been talking about this for a very long time, a decade plus. And, despite all that, we really are not even scratching the surface yet of the scale that drones will be implemented and the value that will come from them. Really what we've seen in the commercial space as a whole, including the energy space, is tests, research, pilot programs. Some companies have implemented some larger internal staff to survey some of their assets, at least some of the time. But we are about to enter a very different generation of drone technology and really robotics in general. And, I think the next decade is going to look quite a bit different.
Thank you for taking the time to visit with me and share all the information about American Robotics. I'm guessing people can go online to learn more about your products.
Yep. They can find us on our website, and we'd be happy to learn more and see if we can help.
Okay. Thank you very much, Reese, and it's been a pleasure talking to you.
Likewise. Thanks, Aaron.